All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is finally solving systems of equations by graphing, which means that we're just going to graph some lines and then look at where they cross. That's pretty much it. Now, later on, there's going to be elimination and substitution, which are really the two main ways to do this stuff, but graphing is, it's the best option when they're already ready to graph, I guess. However, if they don't cross at a nice place on a graph, like let's just say you're given two random equations, like they're not necessarily y equals or whatever, and they want you to find the system, like where they cross or whatever, probably going to be elimination or substitution. So it's kind of like on this one, it's a little different because they're already ready to graph and they're like, hey, graph it, just trust us. So that's what we're gonna do. We're gonna just trust them that they have our best interests in mind here. So let's do like some red and blue kind of stuff here. So we'll have this graph be the blue graph. And in order to graph this, and I'll put a video about how to graph equations, but I'm not going to spend too much time on it. What we're going to do is we're going to have a y-intercept of here, 3. And then our slope is going to be negative 5/3. So our y-intercept, we graph that first. Our slope tells us where to go from there. So we take negative 5, so we're going to go down 5. 1, 2, 3, 4, 5. And then over 3. 1, 2, 3. So like right here. Okay. And then we're going to draw a line through that. And there we go. And then for the other graph, do some red here. Some red. We do the same thing, right? So it's going to be negative 3. Negative 3, it's about right there. So it's a little off there. And then we go up 1 and over 3. Oh, hey, look, there it is. It's right there. So our graph goes like that. Like that. And we'll make purple the answer. It's right here. And it says solve each system by graphing. Now, sometimes the teacher will want you to put like what the point is that they cross at. So if they do, then you would write that point off to the side somewhere, and it is 3, comma, negative 2. And the other thing too is if you're not sure if that's the answer, you could plug it in, and it should work. When you plug in 3 into x in the blue graph and in the red graph, it should give you negative 2 for a y value. And that's a surefire way to make sure that you didn't graph it wrong. Okay, so if you have time on a test or quiz, try that out too. So we'll go ahead and do that on this number 1 here, but if you're feeling pretty confident, you can move on to number 2. You can scrub ahead a little bit if you want. But this is what you would do. Let's go back to blue. So it'd be y equals negative 5/3 times 3 plus 3. Okay. Well, 5 times 3 is 15. Over 3 is 5. Or you can just cancel the 3's. So it's negative 5 plus 3. Oh, which is negative 2. Look at that. So I should get negative 2 because that's the y value. Then, when I check the other one, I should get the same thing. So it's not good enough. If you want to really check it, it's not good enough to just plug it into 1. You can if you only have a little bit of time to check it, but it's not like a foolproof way because it might intersect on 1 and not on the other. So in order to check the other one, we plug it in there too. 1/3. And then 3 minus 3. Well, again, the 3's cancel here, so I'd have negative 1. Oh, yeah, minus, ooh. Oh, no, it's a positive 1/3. I don't know why I put a negative 1/3 there. It's a positive 1/3, so we have positive 1 minus 3. There we go. And we get negative 2. So that tells us that we have the right answer. Like, for real, for real. Okay, moving on. We'll stick with red. Do the first one in red this time. So that's all this video is going to be from here on out. If I run into like a problem that's a little bit different from what we've been doing, then I'll go over that. But from here, as long as we don't run into anything new, I'm just going to graph it and then show you where the solution is so that you have the solution and you can go from there. All right, so I'm going to go up 3. There's a point there. And then I go up 4 and over 1. The slope is 4, which is 4 over 1. You have to have it in fraction form. We can't really go up 4 and over 1 unless I create some extra spaces here. But if we go down in the other way, right, so up 4 and right 1 is the same thing as down 4 and left 1, because it would be like negative 4 over negative 1, which is 4. Right, so then that means I can go down 4 and left 1 as well. Down 4, left 1. And what I'm going to do is, because I'm trying to solve the system by graphing, and I'm assuming that means I'm going to like have a nice place for an answer, I don't really have to worry about doing the actual line. Unless your teacher wants you to, you don't really need to. You just put a couple points on the graph and then move on, because that's actually faster. So then what we do is we go, okay, well let's look at this guy. Right? So negative 2, and then a slope of negative 1, right? So negative x, that's a slope of negative 1 over 1. So we would go down 1 and right 1, but what if we went the other way? Oh, look at that. We'd go right there and get the answer. Where's purple? There it is. And there we have it. So the answer is negative 1, negative 1. All right, moving on. Number 3 and number 4 look like pretty much the same thing. Number 4 is a little bit different, but not by a whole lot. So blue this time. And maybe I'll do 2 different primary colors. Do blue and yellow, make green kind of thing going on here. Right, so bonus, you get to learn about the color wheel a little bit. Negative 1 is the y-intercept, and then we go down 1 and right 2. So if I keep up that pattern, it's going to look like this. All right. And then we want to switch to red. So we go down to 4. And then up 1 over 4. Oh, hey, there it is. Found it. There's the answer. Boom, boom. And that point is 4, comma, negative 3. All right, number 4. This one's a little bit different because this time we have this thing. There's no x. And if there's no x, then there's no slope. But what does that mean? Is that 0 slope or is that infinity slope? Well, it turns out that when there's no x or if there's no y, the better thing to do is to think about it a little differently. When y equals negative 1, where is y equal to negative 1? Well, it's equal to negative 1 right there, right? But y is equal to negative 1 here, and here, and here, all along this horizontal line. Y is equal to negative 1 all along that horizontal line. That horizontal line represents the y value of negative 1. Every point on that graph is something, comma, negative 1. And there we have it. We graphed it. Right, so it's better to think about it a little bit differently when you have a y equals or an x equals. When you have a regular graph like this, then you can just kind of go at it, right? So 4 is right here. Whoop, a little bit higher. Right about there. And then we go down 5. Oh, look at that. We're on the blue line. And right 2. So right there. And let's make that purple. Okay, so that is 2, comma, negative 1. Moving on. If you can believe it, we're already halfway done. Crazy. So now we just have a couple regular functions again. So minus 4, it's down here. Up 3 over 1, it's right here. And again, we're just going to keep doing it. 1, 2, 3 over 1. 1, 2, 3 over 1. Boom, boom, boom. All right. And then we switch to red. Oh, I said I was going to do yellow. Yeah, I need to do yellow. Let me do yellow next time. I keep forgetting to do yellow. Actually, you know what? Let's go. Let's do it. Let's go. Let's do yellow. We'll do blue and yellow on this page. Don't want to switch it up too much, too often, but let's do it. Plus 3. Okay, and then we want to go down 1 and right 2. Ah, there it is. Found the answer. Boom. There it is. 2, 2. Boom, boom. Okay, and then we have this looking thing. It looks very similar to the next graph, but it's in a different place. Okay, well, let's graph it anyway. So here's 2, and we go down 2 and right 1, down 2, right 1, down 2, right 1, down 2, up to left 1, which is the opposite. Oh, we want to do blue next. All right, and then this one. So -2. Okay, but then we're going to go down 2, right 1, up to left 1, up to left 1, up to left 1. Huh, look at that. None of those points are at the same place. What's up with that? Well, it turns out the slopes are exactly the same, right? So it's like on a track. Like if you're running a 100-meter race, you don't want anybody to bump into each other because it's not a contact sport. So you put the lanes side by side going in the same exact direction. You wouldn't make a track where the lanes cross each other somewhere, right? Otherwise, people might run into each other. You make the lanes side by side so that nobody runs into each other. So the same thing's happening here. These lines are going in the same exact direction, which means they're never going to cross. So if they're never going to cross, then there's no solution. No solution. That's it. So we can actually avoid graphing all of those points in the future by just acknowledging that the slopes are the same. If the slopes are the same, so -2 in this case, but the y-intercepts are different, they'll never cross. If they're identical functions, though, if they were both y equals -2x plus 2, then they would be the same exact line, so they would cross infinitely, and the answer would be all real solutions. So I don't know if we're going to run into that, but that's what the answer would be if they were the same exact line. You'd just be graphing one line over the same exact line, so the answer would be all reals. All right, moving on. -1 of x minus 2. Here's -2. And then we go down 1, right 2. Right, down 1, right 2. Up 1, left 2. Up 1, left 2. There's all the points that'll fit on the graph. So then we move to blue. Right, and then we go up 2. There's that. And then we're going to go down 3, right 2. Down 3, right 2. There it is. Right there. 4, comma, and then -4. All right, number 8, and I think that's it, actually. Yeah, because there's the answer there. So as we round this off here, try to talk and work at the same time. If you thought this was helpful at all, then you can like, subscribe, all that kind of stuff, right? That's what you thought I was going to say. But in fact, no, I don't really care about that stuff that much. I'd rather you just get as much help as you can on math stuff in general. Like this guide that I made. It's a free guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's just something that I built, and I was like, hey, I think this could be helpful for everybody if I make a guide based on years of being a math tutor and teacher, and it's just sort of my observation on the types of things that people get right and wrong, and then how you can avoid doing those things, aka get the right answers. So if that seems interesting to you, if you want to check that out, you can go grab that for free on my website, myersmathematics.com. And let me know in the comments below if that guide ended up being helpful to you or not. It could change names in the future. There's our solution. It could be changed to, like, the guide to getting math questions right, which I think is a little more catchy. But the content will remain largely the same, just with a more positive focus, focused more on how to get the questions right and not so much how to avoid getting the questions wrong. And there's our final answer. And that is it for today. I hope you guys have a great one, and I'll see you again in another episode real soon.